On 4.3, we talked about how we could find out if two triangles were exactly the same, meaning congruent, means one would fit right on top of the other. And we learned that if you've got all three sides in one triangle the same as all three sides in another, there was no other way to make it than that they're congruent. There's no other way. You can't make the angles different if all the sides are the same. And we also learned that if two sides are the same to two sides and the angle in the middle of those sides is the same, then again the triangles have to be the same. You can't make two different triangles. Those were both postulates, SSS and SAS. Postulates means that they were a common sense. You didn't have to be proven. ASA is also a postulate. AAS, however, is a theorem. It's a little bit tougher, but it still works. We have to kind of use SAS to prove the AAS theorem works. So let's start with a triangle. So go ahead and draw a triangle on your paper. Make it whatever shape you want to make it. You can make it acute, you can make it obtuse. I'll make it look something like that. Any triangle, yep. And this is up near the section part. And when you get your triangle, I want you to measure just one side of it. So get your ruler, which is on your protractor. You should have a little ruler on your protractor. And measure the one side of your triangle. So for me, this bottom side is 8.5 centimeters. So you're going to measure yours. It can be whatever you decided to make it. So measure your side. And then, yes, go ahead and measure the two angles that are on that side. Don't measure the other two sides. Just measure the angle, the two angles that are on that side. So I'll measure this first angle, and I'm going to measure it to be 82 degrees. So that's just on mine. It could be totally different on yours. And I'm going to measure this other bottom angle. And for me, it's going to be 27. Hopefully you guys are getting pretty good at your protractors by now. You're getting easy to measure them. You're knowing which numbers to use. Always find your 0 point and then go up from there. That 0 might be on the outside. You use the outside numbers. The 0 might be on the inside. You use the inside numbers. But measure that part of the triangle. And as you can see, that's what the ASA is talking about. An angle, a side in the middle, and then an angle. Notice how the angles are surrounding the side. The one side has the two angles on it. So that's what we have here. A side where the two angles are both coming off of this side right here. Now what we want to do then next is to draw a second line that's for me it's 8.5 centimeters. You're going to make it whatever side you need it. So I'm going to get my ruler out and I'm going to measure 8.5 centimeters so that I have the same exact side. 8.5 centimeters. Sorry. .5 centimeters, and then I want to measure my two angles. From those two sides. And I don't want to connect them right at the moment. I mean, I will connect them, but I just want to show you that if I find an 82-degree angle, And on this side, I find a 27-degree angle. And I just draw those two lines in. I don't specifically make it an exact triangle, I just draw the lines. Trying to get it as perfect as possible. Okay, so all I did was I drew in the two angles. So this one, oh wait a second. I went through the wrong lines here. My bad. Okay. This one and this one need to switch. Yes. What was that? This one goes up here like that. And this one goes through this one. I made the two dots and I connected the wrong sides to the two dots. There they are. Two angles. Now all I worried about was getting the 8.5 right, the 82 degrees right, which I almost messed up on when I connected it to the wrong dot, and the 27 degrees right. Okay, so if you look at the pieces that I put up on the board, all I worried about was the side and the two angles. And I let the other two lines just go wherever. I just let them and go as far as I wanted them to. So the question then becomes, if I've got what we would consider an S here, an A here, and another A over here, that means I've got what's called ASA, right? You've got angle, side, angle. Would that, if I had the same thing in this triangle, would that make these two triangles equal? Okay, or congruent? Well, let's check it out. I'm going to go ahead and highlight all this right here, and I'm going to bring it over here and see if one triangle fits on the other. And as you look at it, what do you think? It should, but with my ruler and stuff, it's not exact, but it should. The two should be exactly the same. So it's pretty close, but yeah, it should work. So that's why the ASA is a postulate. Because if you're able to draw the two sides and make the two angles, those two lines are going to cross and they're going to make a triangle the same as this one, if you've made everything the same. So let me read off to you what the ASA postulate actually says. So you have it. ASA postulates says that if two angles and an included side are congruent to the same in another triangle, the triangles are congruent. Okay, so that's what the ASA postulate would tell us. If two angles and an included side, so you got the two A's, but the side is in the middle to where the two A's are off of that one side. If you can see that in another triangle, the only way that could work is that the two triangles are the same. So that would make us have two congruent triangles. So I could put a congruent symbol in between these two triangles, and that would show that these two triangles are congruent to each other. I could put letters and make a congruent statement. Do you remember what a congruent statement looked like? Congruency statement. Sorry. Pleasanton, California. Telemarketers, probably. Okay, so a congruency statement would be triangle, and let's give it some letters. Let's use a B, C here. A, B, C. And then we'll make this one X, Y, Z. So triangle ABC would be congruent to X, Y, Z. Good. That's called a congruency statement. You can get all the letters and sides and angles to match up simply by knowing which order the letters have to be in. And you have to make sure you put everything in the right order, because angle A is 82 and so is angle X 82. So A is first, X has to be first. They are the same angle, they have to be in the same spot. Okay, C is the same angle, so 27, Z's got to be 27 at the end. Angle B is up here at the top, angle Y is up here at the top. So that would match everything up. That's called a congruency statement. That means if you write this statement, that means all the corresponding parts are congruent. Remember the C, P, C, T, C I told you about? Corresponding parts of congruent triangles are congruent. That was in Tuesday's notes. Corresponding parts of congruent triangles are congruent. Okay, so there's your ASA postulate. Again, that's a postulate. The one that's a theorem is the AAS, because it's a lot tougher to draw. And you technically can't draw it. You can't even construct it unless you use SAS. So we had to kind of use SAS to prove that AAS would actually work, so therefore it's a theorem. You remember the difference between a postulate and a theorem? Theorems you have to do what? Prove. Postulates you don't have to prove. They're already proven. They're already common sense statements. Okay, so let's go to the AAS and just take a look at it. We'll draw it as best as we can. We'll do the best that we can do. Okay, so let's draw a triangle again. Just pick a triangle, draw one. Let's just make it something like that for mine. I don't know exactly what triangle it is, but let's just draw a triangle. And you're going to title this one AAS theorem. I'm going to put theorem up there so you know that this one, it still works. It still proves that triangles are the same. It's just a little tougher, and you had to prove it that it worked. So therefore, it made it a theorem instead of a postulate. But any postulate or any theorem you're allowed to use when you do your proofs and stuff, which we're going to practice a few tomorrow. Okay, so let's measure those three pieces. I'm going to measure this bottom side, which is exactly 10 centimeters. Wow, that's pretty good. 10 centimeters. And I'm going to measure two of the angles, but not the two that are on the 10, because we don't want ASA again. This time we actually want AAS, so I'm going to measure one of them that's on the 10. I don't know why I can't make that go to 360. There we go. Okay, so my first angle is exactly 68 degrees. And I'm going to measure the angle up at the top. So measure this angle up here. We'll see what that measurement comes out to be. Okay, looking like it's about 71 for me. Yours might be way different. So this is called an A, and then another A, and then the S. So you've got an angle, another angle, and then you've got your side right here. So it's an AAS theorem. It's an angle, angle, side. Now, only way that we could actually draw that and construct that shape, only way we could construct this triangle and get the same two triangles is if we actually knew what this side in the middle was, which would give us an ASA or an SAS, depending on which way you wanted to use it. So only way that we could technically construct this triangle using those three pieces would be if we had this other piece right here. That's why we have to call this a theorem, because we need to almost kind of prove that those two pieces would be the same. So if I was to draw another 10 centimeter piece over here, so I'm going to go ahead and do that. I'm going to take your ruler and draw the same bottom piece that you have. Whatever yours is. Draw the same piece on the bottom. So I'm going to make it 10. And then measure that same angle, which is 68 degrees. So I'll grab the protractor again. Not ruler. Protractor is what we need. So we take the protractor and we're going to measure a 68 degree angle. Because the problem is you've got your 68 degree angle and you've got your 10. The only question becomes, how far do you draw this line right here? And the only way that you can know it and make sure you get the right triangle, then that the two triangles are equal, is to actually know what that side is. So to construct it, we actually had to use a different theorem to construct our theorem. So I'm going to go ahead and measure this side. I'm going to measure the length of this side. For me, it's 7 centimeters exactly. Wow, that's pretty cool. I got whole numbers. So this to me is 7. So that means I need to make another 7 here. So what I need to do is shorten this line to where it's 7 centimeters. So it's like that. So now what I have is a 68 degree angle. So I have a 68 degrees down here at the bottom. I have a 10. And I have a 7. So what actual theorem do I have, or postulate do I have right now up on the board? I have side angle side up on the board. I have the sides being the same, this side being the same, and the angle being the same. So technically right now I'd have SSS, or SAS I mean, SAS, because I have side angle side. That's the only way we could actually draw this and get the 71 degree angle to come to the right place. So if I do connect it, if you just connected your last two sides, it has to work, because basically before we had the SAS theorem that worked, now it's going to be the AAS that would also work. So if you did that and you measured this angle right here, the angle that you just drew up on top should be a 71 degree angle. if it came out correct. And there's my 71-degree angle, so yeah, it did. So what that tells us is we have another little A up here. We have an S right here. We have another little A. And we had the S down here at the bottom. Now this middle S doesn't even have to be there. You could actually completely take that away, and if you've got those pieces right there, you've just got it the way you see it on the board. You don't need these 7s to be in the picture when you look at it. When you look at it, you just need to know that these 2 angles are the same and these 2 sides are the same, and the 2 triangles will have to be exactly the same.
So you gotta use the SAS.
To prove it, we use the SAS. That's why now that it's proved, we have to call it a theorem. So that's the AAS theorem, and it does work for congruent triangles. It does work for AAS. So you could actually put down that these 2 triangles are congruent to each other. You put your congruent symbol in between them, and that's called the AAS theorem. Angle, angle, side, congruent to angle, angle, side. Now, I need you to know one other thing here. Yes? One other thing I need you to know is that whenever you have 2 angles and any side, 2 angles and any side the same, it's congruent triangles. You could have the side between the 2 angles, like we had on the other slide, or you could have the side after or before the 2 angles. The triangles have to be congruent with 2 angles and a side. That's not the case for 2 sides and an angle. Remember SAS worked, but SSA, or backwards would be a bad word, doesn't work. Remember, 2 S's and an A don't work if the A is not between the 2 S's. So 2 A's works no matter what, as long as you have another side. 2 A's with any side, it'll be congruent. 2 S's with another angle doesn't always work unless the angle is between those 2 sides. So keep that in mind. The A's are fine. If you got 2 A's on a side, you're going to have congruent triangles. But you have 2 sides at an angle, the angle's got to be between them. And then 3 sides is great. 3 sides is easy. That's going to have to be congruent triangles. So that will always work. Okay, so those would be congruent statements. We could make a congruency statement there if we needed to. All right, those are all the notes for 4.4, ASA and AAS. All right, let me stop this.